Hey everyone, I hope you all are safe and doing good. So let's see one more sorting algorithm, that is merge sort. We have discussed now bubble, insertion, selection. All the three are elementary or the basic one, having time complexity, sometimes n square, sometimes in best case order of n. Plus quick also, quick sort that take time complexity n log n. Let's see what is merge sort, but quick sort is not stable. Okay, this one is stable. Now, we know that they see the name is merge sort. So we are going to merge something in this for sure. Before going to merge sort, I hope you remember we have done few examples, few lead code questions, merge two sorted list, merge k sorted list. How we merge? I guess you remember. Suppose this is I have two lists. This is my list one, this is my list two. Sorted list. This one is sorted, this one is sorted. Now I want to merge these two lists. So that is my output list. How you are going to merge these two lists? What are the steps we have done? Like we start from here, like I is here, j is here, suppose. So we compare this with this, the very first element of both the list. Which one is smaller? That element we put in the output list. That is 4 is smaller, so 4. Now increment this one. So here I have now j. J is here, right? Here I can say j. Now compare this with this, 5 and 12. Which one is smaller? 5. I put 5 here. Now I increment I. Now 10 with 12. Which one is smaller? 10. Put 10 here. Now increment I. 11, 12. Which one is smaller? 11. Put 11 here. I is increment I. 12 or 20. Which one is smaller? 12. Put here. J plus plus. 20 or 17. Which one is smaller? 17. Put 17 here. J plus plus. J is here now. 20 or 25. Which one is smaller? 20. Put 20 here. And I would be at the last. I mean, I is like out of bound of this list. Now we stop. What we do? Whatever element in this second list, we just put here. Something like this. 25, 29 and 30. That's how we do merge two list. This thing we have already seen. Basically, we need only two pointer. One is pointing to this, one is pointing to this, and we keep comparing the elements, each node from both the list. Which one is smaller? Put that in the output list and increment that node. Move further in that list. Right, like this we do. This is how we got the new sorted list. And this is sorted, we know. This is sorted. I think it's not that much tough. But what if I say that now we are having two different lists, but I have now, suppose within a same array, I consider that I have this array, and within this I am having two lists. I mean, how I'll have two lists or two sub arrays, you can say, two sorted. Let me just draw this here. Now I have, suppose that the situation is I have two sorted lists or two sorted like sub arrays within a single array. This is my array. So it's like till here I have, you can say, one list. Till here I have second sorted list. We have divided this into half. So it's like you can say middle. This is my, I can consider low. This is my high. And here I have mid. This is middle. Yes. Low plus high divided by 2. 0 plus 9 divided by 2. That is, if you take into value, that is 4. So 4. At 4 index, this is mid. Now, first half, second half, both half are sorted. Now you have to merge these two lists. But these are not in a different list. These are within a single array. It's not that much tough. It's easy. Same process we have to apply. So we just take a separate array of same size. And now we compare first element of this list and first element of this list. So basically, now I would be here and j would be here. Means I would be, okay, whatever the low is, j is mid plus 1. J is mid plus 1. Hypothetically, these are two lists, but actually these are within a single array. I'm considering this is sorted part, this is second sorted part, half half. Now I have to sort this complete array. So what I do, I know this half is sorted, this half is sorted. So I can consider this is a separate list, this is a separate list, and I can just merge these two lists. How you will do? Compare this with this. Which one is smaller? 3. So I'll put 3 here. Suppose let's take temp, a different array. And I'll move this j here. Now compare this with this. Which one is smaller? 5. Put 5 here. Now I'll move I here. 10 and 12. Which one is smaller? 10. I would be here. 11 and 12. Which one is smaller? 11. Let's put 11 here. Increment the I. 20 or 12. Which one is smaller? 12. Put 12 here. J plus plus. 18 or 20. Which one is smaller? 18. Put 18 here. J plus plus. 21 or 20. Which one is smaller? 20. 20 put here and I plus plus. I plus plus. 30 or 21. Which one is smaller? 21. J plus plus. 25 or 30. Which one is smaller? 25. Put 25 here. J plus plus. But J is now out. I mean, J is basically we check. J is less than equal to high. Till then we check. Now J is greater than high. Stop. Now check. We know that in this list still one remaining element. There is still one element left. 30. So we just put 30 here. And this is my sorted list. And now if you say that I want to copy this, you can just copy this temp to here only. So you will say that now you get the sorted array. So in this case, to merge using this process, if you have two lists within the same array, we need a temporary array, separate array of same size. Extra space we need. Then we copy this to this. Right. In this case, what is the condition? I'll move I from 0 or from low to mid till less than equal to mid. Once I becomes greater than mid, stop. And j from mid plus 1 to high. We start from mid plus 1 until high. Till j less than equal to high, we keep repeating. Once j is greater than this means this list is exhausted, stop. Now whatever in whatever list the remaining elements are there, elements are remaining, just copy the same, all the elements in the temp list, temp array. This is how we merge. We can apply merging if two lists are within the same array. So it's like we have divided this array into half. We are merging these two half like this. So if you write this merge method, how you will write? Let's see. I'll write this merge. So what you need to merge, whatever the array given, plus it's hypothetically two arrays, but these sorted part or sorted list are within the same array. I need low. I will need low. I'll need mid. Where is the mid? And third, what you'll need? High. These three things you need and array you need. So this merge, this method is really important because the same method we use in merge sort. The same method, the same process, the same procedure. So first understand this thing. It's really important. Have you write down this? Now we will take I and j as well as now one more list you have like temp. So I'll have one more array int temp. Let's create the array of same size whatever we have, the length of the array. This array length arr dot length is the same size. We create a new temp, and obviously we have a separate variable I, j and k also, because here we are storing so k plus plus k plus plus like this. To traverse this we need a separate variable. So we need extra 3 variables. You can say I, j or k, any variable name you can take, 3 variables. At first I is equal to low, j is equal to mid plus 1. J will start from here, mid plus 1, right? And k is equal to same whatever the low is. Rather than 0 here, let's say k equal to low. You will get to know this thing because recursively when you call a given array merge, then k would be whatever the low is. So rather than 0, let's take it low. Whatever the low, that would be my k. Right. We are having these things. Now what you do? Just write down a loop. While we keep moving, while we know I is less than equal to mid and my j is less than equal to high. Till then we keep moving. And what we do? First we compare, then we compare if the element which is at ith index is less than the element at jth index. We compare 5 and 3. If ith index element is less than jth element, then what we do? What we do? Then we just write in temp of, in this array, in at k index, I will store whatever the array of I. Then we increment I plus plus, and then we increment k also. I plus plus and k plus plus. Yes. So after putting at first, let's have an array here. At first we have everything 0, 0, 0. So k is here. So I is here, j is here. Compare this and this. But in this case, this one is smaller. So we'll put 3 here and move k also, k plus plus. In this case, we move j. If this is the situation, otherwise, else we put in temp whatever the element at jth index. And then we do j plus plus and same k plus plus. Like in this case, 3 is smaller. So j is pointing to here first, I is here. So we'll put this element 3 here, we do k plus plus, we do j plus plus. Now j is here. And we keep repeating this step for this while loop. So these are in this while loop. I hope you got it. Now, one more point. The same element. If I have 5 and 5 here, 2, 5. So where you will put equal, or you can say the same element, the left or the right part. It's up to you. Okay. So now I put here, if this is less than or equal to array of j, both are equal, 5 and 5. Suppose I have here 5 and 5. Both are equal. So if I write here only less than, then this condition is not true. Yes. So if I only write here less than, then array of I is less than array of j. No, it's equal. No means we go to the else part and we put in this temporary array this 5, and then k plus plus. Right? So in this case, if you implement merge with this logic, then it will not be stable. Because the order of these, relative ordering of these same elements should be this 5 should be first, this 5 should be after this. But here, whatever logic we have written, this 5 is first, then we write this 5. Right? So better, because this merge sort is stable. So this is stable only if you write here, only if you implement this with less than equal to. Now see, if less than equal to, less than or equal to, yes, array of I is less than or equal to array of j. It's, yes, true. True means we put whatever I, this 5 here first, and then I plus plus. Now it's stable. Ordering will not be changed. I hope you got it. Okay, everything while this I, j, this condition is true, till then we keep repeating, we keep adding. But at last, maybe like in this case, j was high, j was out of this, j becomes greater than high. So we'll not enter here, because to enter into this while loop, both the conditions should be true. But now in this list, there is still one remaining element, 30. So this also you need to take care. Maybe the situation is this list is exhausted and we have element in the second list. So you have to put this also. Now after this, what we write? After this, we can write here something like this. After this while loop, after closing of this while loop. Yes, we close this else here, then we close this while loop here. We write, now whatever, suppose I write while I is less than equal to mid, same while loop you can write. We just keep adding temp of k is equal to whatever ARR of I, and I plus plus and k plus plus. Closing. One more while loop after this, while j less than equal to high. Maybe this list is exhausted. We are still having remaining element in this. So j less than equal to high. Till then, we just keep adding in this temporary array, whatever at jth index. Keep moving j plus plus and k plus plus. That's it. This step is done. Now one next last step is we have to copy this to this. So that is also not tough. We just write down a while loop or a for loop. I is equal to 0 or I less than less than k, right here, right? Whatever the k, this and I plus plus, or whatever the length of this array. Why I'm writing k, you will get to know. Suppose rather than k, let's write here I is equal to, for now, after that we update this, I less than temp dot length minus 1 and I plus plus. Till then we will copy array of I is equal to temp of I. That's it. This will copy this temp to array and you will get the, this would be a sorted array. This is how we merge two half of the array. This is first half, this is second half. We merge these two. This is the merge function, merge method. This is really important. Same, I have suppose more than two lists. So here I'm merging two lists. So it's two-way merging. If suppose I am having more than two lists, I have here list 1, list 2, list 3, separate list 4 maybe. So yeah, you can merge same. We have discussed how to merge these lists. List 1, list 2, list 3, list 4. We compare first element, whichever is smaller, we put that in this list here. Suppose list 2 is smaller, so we increment this, then we compare this, like this, we comparing and we keep adding. We know. So here we are merging 4 lists. So we can say it's a 4-way merging. 4-way merging. If we merge 3 lists, 3-way merging. If we merge k list, k-way merging kind of thing. Right? Or it's not that that is the only way. How you can do is, we are having suppose 4 lists. So we can merge this with this to get a list. We can merge this with list to get a list. Now we can merge this with this and finally you get sorted list. These lists are sorted. We are having 4 sorted lists. You can merge these two, then finally these two and you can get. That is also a way. There are different approaches. Otherwise, you can merge these two, then this list 3 with this, then whatever the result you will get, list 3 with this, then whatever the result list you will get, this 4 with this, like this. That is also a way. 2-3 ways we have already discussed when we are discussing lead code question of merging list. Okay. But if I follow this approach, this, then these two, then these two. So at a time we are selecting pair of list, two lists. So this is two-way merging, because we are merging at a time two lists. These two, then finally these two, and final list you will get sorted list. So this is two-way merging, and exactly this process we use in merge sort. Yes, I hope to somewhat merge is equal to you. Clear to you. How we merge two sorted list. Yes, that is the main, you can say the main process in merge sort. So if I say, now I have an array, let's suppose. Now I'll discuss what is merge sort, right? So this array is given to you. You have to sort this in ascending order. Okay. Applying merge sort, this sorting. So here, if you say that, let's divide it into half. So I have till here, this is first half, this is second half. And we can merge, then we'll get a sorted list. But no, because is this sorted? Is this sorted? No. So you can't apply it directly, like merge to sorted list. These are not sorted. Okay. You remember, you know that if in a list there's only one element, then it's sorted. We know. So we keep dividing this. Can we do this thing? We keep dividing this. We assume that this, I assume that here I have 10 lists or 10 sub arrays. One, this is separate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 separate list I'm having. Each list is sorted because only one element I'm having in each list. So one element means sorted. Now I keep merging. Have to merge. These two lists I can merge, then these two, then further. Like this we can do merging kind of thing. At last you will get sorted list. We know how to merge. So there are basically two steps in merge sort. First step is we divide. We divide the array repeatedly into halves until you get in each list or in each subarray only one element. We keep dividing, we keep dividing, we keep dividing. That is first step. Second step, we merge those those sorted list, and ultimately you will get a finally sorted list. So basically the two steps are there only in this sort, right? Why we divide, I hope you get, because we can easily merge. If I have two sorted list, I can easily merge these two sorted lists. We know the algo, we know the process. It's not that much tough. And time complexity also for that not that much like high. It's good. So keep divide. First, let's divide into half, right? So we divide into half. So let's divide into two half. Its division is hypothetical. 5, 10, 11. You know na how to divide a complete array. You are given a complete array. You know here we have low, here we have high, whatever the array length, dot array length minus 1, then high plus low divide by 2, you get mid here. And this is how basically we have divided this into two half. Hypothetically, we are just dividing. It's not that I take a temp1 array, temp2 array, and then I divide this and copy that element here. No, hypothetically, I'm just dividing. Hypothetically, not actually. Actually, just I'll consider this one half within the same array. I hope you got it. In second array, I have 15, 4, 18, 25, and 20. Recursively, we keep dividing until you get in each list, each sublist, only one element. We keep dividing this also. Divide into two half. So here we have 1, 2, 3, 4, 5 elements. So we can have like low would be for this 0 and high would be 4. So 0 plus 4 divided by 2, 2. 1, 2. Here we have mid. So I will take 5, 10, 11 here and 3 and 1 here. Okay. Or you can apply your process till mid, till high in this and 5 to here. Left bias or right bias is up to you. It's up to you how you do this. Right? I've divided this. Same. Divide this into two half. 15, 4 and 18. And here I'll have 25 and 21. Is this sorted or is this having only one element in each list? No. Again, keep dividing. Keep dividing. We have 5 and 10. Now we have 11. 3, 1. This list 15 and 4. This list we are having only 18. We are having 25, 21. We keep dividing. Here we have 5 in two half. 10. It's only one element, one element. Here we have 15 and 4. 1, 1, 1, 1. So now we stop. We keep dividing repeatedly until each sublist have only one element. Now I can say that this each sublist is sorted. So I have basically 10 sorted list in this single array. That's why I was discussing. I was saying you. So you just consider this one list, second list, third list like this. See, 5 is one list, 10 is another list. Hello. 10, then 11, another list, 3, 1, 15, 4, 11, 18, 25, and 21. So this is what we divide. That is first step is done. Divide. Now we merge. Yes. So how we are going to merge these two. So how you divide, let's see. If I draw the recursion tree for this, then how we write? So suppose if I write the code till here, how you will write? Pseudocode, I'm just writing pseudocode. So I'll simply have a method name merge sort. Here I'll have array. Then we have low and we have high. So if low is high, till then we divide, keep dividing. If low is less than equal to high, if low is less than equal to high, it means there are more than one element in that list, so we can divide. See, for this list, low is here, high is here. Low is less than high. Yes, so we keep dividing. But for this list, low is also here, high is also here. Low is not less than high. Means we cannot further divide this. Stop. So first you have to put one condition. If low is less than high, then we keep dividing. So first we calculate mid. Mid is equal to what is the formula so that we can avoid that overflow condition? High minus low divided by 2. This. We calculate mid. And now again we call recursively. I'm just writing recursive method. So I'll again call merge sort. The same. I'll pass array. Low is whatever the low plus mid. Mid is what? Because we have divided this. So mid for this is we again divide this. So mid for this is what? From 0 till this list is low is 0, but high for this list is whatever the mid. That would be high because high, this is low for this list. This is high. High for this sub list is whatever the low. Sorry, whatever the mid. Okay. So you have to write here low and mid. This is my first half. Again, I divide this again. Secondly, for right sublist, for the right half array, for the right half, for this half, this low is what? Mid plus 1. High is as it is. So low is mid plus 1 and high would be as it is. So this is how we keep dividing this list. Keep calculating mid if low is less than high, and we keep dividing. Once low is not less than high, we stop. But it's not that division, that's it. No. We keep dividing, and after that, third step is also there. We merge. Merge method I have already discussed. See, we keep dividing. First, I'll call this. Okay. So recursively, when we call for this, then keep dividing this, then this, then this, then this. Then ultimately, we merge these two. Only one element. We can't further divide. Then we merge these two. Sorted. These are two sorted lists, we assume. And we merge these two. That it becomes 5 and 10. So before moving back, you have to merge also. Then we move back. Then we 11. You can divide this? No. Then merge this and this, like this. So after dividing, merge. For merge, what you pass? Array, low. First list is, we divide, suppose this list. So we merge this and this, suppose this and this. Previously we have seen. So the list is from low to mid. And this, second list is mid to high. So we pass only low, then mid, then high, and array to merge. Right? Because once we have the array, once we have low, once we have mid, once we have high, we can know that this is my first half, mid plus 1 to high is my second half. I can merge easily. Right? So that's how we merge. These three things we need to do when low is less than equal to high. Now, I hope you can say this. Now, let me just draw the recursive tree for you so that you can get it better how the things are working. At first, we call this merge sort. Okay. We pass array, then whatever low and whatever the high. So I'll not write complete merge sort. I'll write simple ms. Merge sort. I'll pass whatever the array, but I'll not write down here array. I'll pass only low is 0 and high is 9. So at first call, this is passed 0 and 9 at first. Now see, low is less than high. Yes, we calculate mid like this, and we call again merge sort, and merge these three things. Recursively these two, and then we merge also. Merge method we have already seen. The same code is there. Okay. Now, low is less than high. Yes. So we call here again merge sort, and we pass, because we know mid is right now 4. So here we pass 0 and 4. Low and mid for this. Second, okay, this recursive call will be executed. But yeah, we have three here, three things. 3 calls. So second recursive call for the right half. For the right half is mid plus 1. Mid is 4. So low would be started from here till high, 5 and 9. This would be passed for low and high. And at last we are having merge. In merge you pass array, low, mid is 4 and high is 9, like this. Yes? Then this, first, then this. This would be called recursively, this will again call. So merge sort. Now I'll consider my list is from 0 to 4. 0 to 4. Again say low is less than high. Yes. Again calculate mid. Mid is 0 plus 4 divided by 2. So it's 2. So mid is this. Mid is this. Okay. Now again we call here merge sort. So after calculating again we call here merge sort. We pass low and mid. So low for this is 0. Mid is we have calculated, that is 2. For right half, mid plus 1. Mid was 2. So 3 and 4. High is 4. Next call is for merge. Here you pass the array. Low, mid is 2 and high. Like this. Again this would be called recursively merge sort 0 and 2. Now my array is from this to this. 0 to 2. This. 5, 10, 11, 0 to 2. Again because low is less than high. Yes. For this, low is this, high is this. Low is less than high. Yes. Again divide. Again divide. Calculate mid. So 0 plus 2 divided by 2, that is 1. Mid is 1. So 0 for next. Recursive call, we pass low and mid. So 0 and 1. Next recursive call, mid plus 1, that is 2. And high is also 2. Then third step is we call merge, passing low. For this frame, low is 0, mid is 1, and high is 2. Yes. Again for this 0 and 1. Again would be called 0, 1. Low is less than high. Would be checked. Yes. Again calculate mid. Calculate mid. We call mid is 0 plus 1 divided by 2. That is 0 itself. So mid is 0. So for this, low is this, high is this. Again you have to divide because low is less than high. Again divide. Mid is also same, 0. So we call here 0 and 0 for next. Then ms merge sort, we pass mid plus 1. Mid was 0. So 1 and 1. High is also 1. And the third step was merge low, mid was 0 and high is 1. High is 1 for this because for this frame we are calling all this. So for this high is 0, 1. Now for this again further would be called 0, 0 would be passed. 0 and 0. Is low less than high? No. So will not enter here. So will not enter here means back. That frame would be out from the stack frame, that recursive frame. So we will not enter here. So this is 0, 0 means we have 5 here, the list 5. So will we go back? Back means then the next 1, 1. Is low less than high? 1, 1. We have only 10 in this list. Is low less than high? No, low and high both are same. Again, this would be out. Now this one, merge 0, 0, 1. So now see merge 0, 0, 1. 0, 0 and 1. So like this. We have to merge 5 and 10. For us, 0 and 0 means mid is 0, low is 0 and high is 1. So basically we are having this is two sorted list in a single array 5 and 10. We consider something like this because we are dealing with this only right now. We are here. Now you have to merge these two. After while calling this method, merge we have already discussed. We will take I. So I would be low. We will take j. J would be mid plus 1. Mid is 0. So j would be here. Now we check. This is less. We take a temporary array of this much size. So we have sizes this much only. Right? At first we have 0, 0, 0. And k is pointing to low. Low is 0. So k is pointing to here. Okay. Now what will happen? Same process. Let's just revise this. I'll not repeat it. This process. I'm just there dry run this program. Okay, I hope you remember this. Now what we do? I is here, j is here. Now find out. Is this element less than equal to j? Yes. So we copy this to here and k plus plus. Now k is here. While I less than equal to mid, but I also becomes plus plus, so I is pointing to this. Mid in this case was 0, but I is now 1, so I is not less than equal to mid, so we stop. Now we go to the next. After that main while loop, we have written 2 while loop. Whatever list in we have remaining element, we just copy. So here we have just done. We are remaining with this. In this list, we have, yes, one element remaining. So while j less than equal to I, we keep copying this to temp. We copy this and k plus plus. Now k is here. J is also plus plus. J less than equal to I now? No. So stop. So like this, we have merged two sorted lists, this 5 and 10, this 0, 1, 2. K is now, see, 2. K is now at this point 2. Okay. But one more step is there here. After these two, we have a one more for loop. This loop will run. Here I have just written in this from 0 till temp dot length. Now here the problem is, because you have to modify this. Now see, observe the problem carefully. I is 0 and I should be less than equal to temp minus 1. In this case, we create a temp array of equal size. So temp size is 10. Everywhere now we have 0, 0, 0, 0, 0, 0, 0, 0 by default. Yes. So now this loop will run 0 to length minus 1. So 0 to till here. And basically copy all the element of this to array. So if the loop will run from 0 to temp length minus 1. Okay, 5, 10 would be here, but here we have 0, 0, 0, 0, 0, 0 finally. And if we copy this to this, because ultimately here we have 0, 0 by default. So we are going to low stir data, right? So while implementing merge, sort, this for loop you have to change a little bit. This was generally I have discussed. So this is how we merge to simple, we are having within a single array two list. So to write down this in merge sort, have to write, suppose let's keep it I is equal to 0. Let's keep it, but you have to change this condition, because I want to run this loop from here to here itself. That's it. Because right now I have just sorted these two, 5 and 10. So just 5 and 10 I want to arrange. That's it. I want to run the loop only 2 times. Yes, the condition you can put now based on k. Because k size is 2. Whatever elements you have at that particular time in this temp, your k would be that. So here, rather than writing this, I'll write this should be less than k and I plus plus. I 0 and I 1. Once I becomes 2, k is also 2, we stop. So only 2 times this will run, only 2 times. That's exactly you want. One time 5 would be copied, second time 10 would be copied. So basically, after this much array is sorted. And basically 2 lists we have merged. Yes? Okay. Now let's see. So after merging, this becomes 5 and 10. Now see, after that where you go? First, this recursive call, first this call. Then the numbering is how, in which order the recursive call is made. 2 is this, 3 is this, 4 is this, 5 is this. Now after this, no further call. We go back. Then 6 is this. Then 7 is this would be executed. After this, for this frame, everything is done. So we go back here. So that is 8. Yes. Now 2 and 2. So here we have 2, 2 means only 10. Sorry, only 11. Further low is not less than equal to I. So obviously, we will not further divide this. So this is done. We go back. We go back means third is still remaining. These two are done for this frame. This and this. So now ninth, we call this method merge. Now what we merge here? 0, 1, 2. So basically 0, 1, 2 means 0, 1, 2. This 5, 10, 11. This you need to merge. Although these are in already sorted order, you can change it a little bit if you want. Let's suppose here I have 15. So here you will have 15, 15, 15 and 15. Now after merging these two, this becomes 10 and 15. 10 and 15. Okay. This was 15. So it becomes 10 and 15. So after this array becomes here would be modified. Here we will have 10. Here we will have 15. So ultimately the changes are done in this within the same array. This is hypothetical everything, this division and all. I mean this, there are no separate arrays. Okay. Now here also we have like 15 and 10. So here we will have after merging 10 and 15. Now we have to merge this 0, 1 and 2. So low is this, mid is this, high is this. So basically 10, 15 and 11. This 0, 1, 2. So I would be this, mid is 1. So j would be this, mid plus 1. Simply merge method we are calling. So this is basically the half, two half I'm having. This is my list one sorted, this is my second list sorted, and I have to merge. I have to merge this with this. So this within this separate we have this temp array. So we just copy paste here. Now we start comparing this with this. Is 10? Yes, 10 is less than 11. So we put 10 here first. We simply do k plus plus. So k is pointing to here, right? And I plus plus, I is pointing to here. Now compare this with this. Now 11 is smaller. So we just copy 11 here and k plus plus and j plus plus. Now j is, we are done with j. So remaining is 15 only. We just copy here 15. And then again k plus plus. K is here. Now k is 3 in this point. Now we do what? Whatever in temp we just copy here. We start from 0 till k. Till k means only 3 elements. 0, 1, 2, only 3 elements we need to copy paste. 10, then 11, then 15. So now in this array we are having basically here 10, here 11, here 15. This is how things will work, right? So for this merging, I'll not change here, I'll just write here. You have to merge this 10, 15 with this. So I'll have 10, 11 and 15. This is done. Now we go back. This is 9. Go back. This is done. So then this would be called 10. 3 and 4. Now see. Is low less than equal to high? Yes. Now same for this. We call, because low is less than equal to high. So 3 times that recursive call merge sort. We pass low. Low for this is 3. Mid. Mid is, low is this, high is this. 3 plus 4 divided by 2, 7 divided by 2. That is 3 itself. So mid is 3. For second merge sort, we are calling mid plus 1. So we start 4 and high is 4. And then we merge. Merge, we pass low. Low is 3. Mid is 3. And high is 4. Now further, low is 3, high is 3. Low less than equal to high? No. So we stop. Okay. So next call, first is 10. This was 11. So 3, 3 means I have only one element. So no further call. That is 3 I am having only here. So we go back. Then this would be called 12, 4, 4, 4, 4. We have here one element. Is low less than equal to less than high? No. So we go back. Now this. Third is this. Now we merge 3, 3 and 4. So 3, 3 and 4. 3 and 1. So basically we are merging these two now. Because here in merge we are passing low is this. 3 and 4. 3 and 1. Only this portion from this array. Low is this, high is this. So I would be low. Mid is 3. So j would be mid plus 1. That is here. Compare, keep comparing. In a temp, we just, now in temp array, we just write down. We just, obviously, these are, we separate two lists. So we take a separate temp list to merge these two. Compare this with this. Which one is smaller? One is smaller. So we put 1 here. So it's like that. If we write here, so basically how we write? At temp of k, we write whatever the element is less. And right now temp is 3. Right now temp is pointing to this. Yes. It's not that we just write here 1. 1 is smaller, so 1 I'll write here, then k plus plus. Now k is pointing to this. K becomes 4. Now this is done, so only 3 is remaining. So 3 I'll just paste here. Now k plus plus. K is pointing to this. Now k becomes 4, 5, 6, 7, 8, 9, 5. Yes. Now see, k is here. K is 5 now. Now obviously we have to copy this to this. Okay. But this are already done. These three. We have to copy this 1 and 3 only. This is right now my temporary array, this part only. But here, while you are copying, this is the loop where we are copying. So here you are right, starting I is 0 and I is less than k. So you will again copy here from 0 to this. Yes, there is no need. We just have to copy from this 3, this to this, this to this. So start from 3 and 4 till less than k. K is 5, we stop. But we have to start from 3. So you have to initialize I with 3 is what for this frame? Low. Wherever the low is right now. From low till k we copy. So here rather than 0 we can write I is equal to low. So right now I is equal to low because we are in this frame. For this frame low is 3. So I would be 3. I would be 3. I would start from here. So first we copy this 1, then 3 and then we stop. Because till less than k we have to copy and k is 5, so stop. Okay, right. We will update, we will you can say modify this a little bit more, because here in this case I'm just taking an temp array every time we are calling this merge. And see, we are calling this merge here how many times? See, for every frame we are calling this merge, merge, merge. So whenever you call, a new temp array would be created if you write down that loop. But that's exactly not we want. So I'll not create the array here, this temp array here. I'll create in the main and I'll pass my temp also, because this will wastage of space. Right? Now next, this is done. This is done. So here we have to merge these two. So it becomes 1 and 3. Go back. This and this is done for this frame, but third, still we are having this left. So after 13, it's 14. Now we merge 0 to 4. So basically 0 means low. Low is this. Mid is 2. Mid is 2 and high is this. So basically from here to here. So this is done. This merging is will be there. This merging, then this merging is 1, 3. So we have to merge this and this. 10, 11, 15 and 1, 3. So after same merge, you will merge method you will follow. You can write in that. And after merging, you will get here 1, then 3, then 10, then 11, then 15. So this half is sorted till 0 to 4. Till 0 to 4 because this is high. Yes, till this. We go back. This is done. 14, then 15. This call would be there. Now this. Now you have to deal with this half, 5 to 9. Same, we keep dividing first, then we keep merging. Yes. So if you write here, first how this will be called? 5 and 9. So low is 5, high is 9. So is less than high? Low is less than high? Yes. We calculate mid. Mid would be 5 plus 9, that is divided by 2. That is 7. So first we call here 5 and 7. Then again merge sort. Mid plus 1. Mid is 7. So 8 and 9. Then we call merge. Pass low. Mid is 7 and high is 9. For this again we call. Right? So let me just draw this 1, 3, 10, 11 and 15. Now I'll call this merge. For this recursive call 3. Low is less than high, low is 5, high is 7. Yes. So again call merge sort. Low is 5. Mid would be 6. 5 and 6. Now we call merge sort mid plus 1, that is 7, and high is also 7. Then again we call merge. Low is 5, mid is 6, high is 7. 5 and 6. Again for this, call again merge. Merge sort. Low is less than high? Yes. Okay, fine. Again, mid would be calculated, that is 5 itself. Okay. So we call 5, low and mid 5, 5. Then 5 plus 1, that is mid is 6 and 6. And again we call third merge, passing low, that is 5, mid is 5 and high is 6. Now further this, is low less than high? No. So go back. So basically what will happen? The 13, 14, this is 15 call. Then this would be 16 call. Then this would be 17 call. Then this would be 18. It's the order I'm just writing. 18. Now here we have one element 5. 5 means only 15 I am having. No further call, go back. So next this call 19. 6, 6. Low is less than I? No. Go back. That is we are having only 4. Now 20. This would be done. 5, 5, 6. 5, 5, 6. From here to here. So this is one list. This is second list. Sorted. Merge. After merging, after calling merge, this would be 4 and 15. First in temp array, then from temp array, this would be copied here. Right? So this would be switched with 4 and 15 in this array. Now we go back. This is done. So this part is done. Now this part. 21 is this. 21 is this. 7, 7. Low is less than I? No. So go back. Go back means we are having only 7, 7 means only 18. Only 1. Now 22 is this. Now we merge 5, 6 and 7. This. 5, 6 and 7. So till now we have merged 4, 5. This 4, 15 plus 18. We merge these list. So after merging this becomes 4, 15 and 18. This merge is done. It's 22. Go back. Now this would be 23. This one 23. 8 and 9. No, low less than high? Yes. Again it will call. So I'll just simply write down this because I don't have space. So here. Merge sort. Low is 8. High is 9. What is mid? 8 plus is 17 divided by 2. That is 8 only. So again we call. So we pass low 8 and mid. Mid is also 8. Next recursive call would be from mid plus 1. That is 9 till high. High is also 9. And then we call merge. We are passing low. Low is 8 for this. Mid is also 8 and high is 9. So 23 this. Then next 24 is this. Is low less than high? No. Go back. Here we have only one element, that is 25 in this list. Go back means 25. This would be called. This would be executed. 9 and 9. Low and high is 9, 9. So is low less than high? No. Go back. 9, 9. We have 21. Now this would be executed. 26 number. Now we merge these two. 8, 8 and 9. So basically 8, 8, 9. These two. Low is 8. Mid is 8. And 9 is that. So basically these are two separate lists. Sorted list we merge. We merge these two. So it becomes 21 and 25. 21 and 25. After 26, we go back here. 26 is done. Now this 27. Now we merge. This we have done. This we are done. So two sorted lists we are having. One is this 4, 15, 18. Second is 21, 25. We merge now these two 5, 7 and 9. So till here. Low is this. Mid is this and this. So we have two sorted lists 4, 15, 18 and 21, 25. We merge these two and this would be here 4, 15, 18 after merging 21, 25. So we're done with this. 27 is done. We go back. Now we are done. Only one is left, this. So now we merge this plus this. So finally, this half sorted, and now the same thing we have discussed here, that is we have this half sorted, this half sorted. So now we have to merge these two. Simple. Yes. So after merging, we call low is 0, mid is 4, high is 9. Same. So I would be this, j would be from here, and we keep comparing elements and we keep adding in temp, and after that we can compare the we can copy from temp to here. I guess you got it. Yes. So after that you get here a sorted list. This is how merge sort work. This is the complete process. Divide, then merge. First keep dividing and then we keep merging. So first these two, then this with this. So it becomes 10, 11, 15. Yes. Then this with this, 1 and 3. Then this with this, 1, 3, 10, 11, 15. Okay. 1, 3, 10, 11, 15. Then we go back the right part. So first we merge these two, 4 and 15. Then after this, third is this. So we merge this with this. That is 4, 15, 18. Then the right part, first we merge these two, 21, 25. Then we merge these two. It becomes 4, 15, 18, 21 and 25. At last we have this list, and this list we will merge these two. So finally you get merging, finally sorted array. So this part was divide, after that merging. But this is hypothetical thing. Everything is happening within the same array. We are not taking any extra array. We are taking only temp, which is equal to the size of this. So that is space complexity. That's why space complexity in this case is n. So in some cases when you don't want to take extra space, there we can't use merge sort. Right? Now this is how we call merge sort, and this merge method we have already seen. This is my merge method. Exactly same. Only we have to change a little bit here. And rather than here defining this temp, we will pass this temp. We just take one time in main and we pass this. Now what about complexity, time and space complexity? See what we are doing here. First we have n element, then we keep dividing n by 2, n by 2. Then n by 4, n by 4. Like this we keep dividing till we have only one element. Yes. So it's like something like this. N element we are having. Then we have two list having n by 2, n by 2 element. Then n by 4, n by 4. This list will have n by 4. This list have n by 4. Like this, n by 8, n by 8, and till every list is having only one element. Till then we keep dividing. Right. So it's like that complete binary tree or full binary tree. Right. Now see, at every level, the work done at every level. So basically, merge sort, this is how we are like dividing this. But actually the work is done when we call this merge. Work done per recursive call. Per recursive call is in one recursive call, this is simple comparison order of 1. We are calculating mid constant time complexity. This we can ignore because these are recursive call. We are recursively are calling. But now this, we can't ignore this. One extra method we are calling merge in every recursive call. So for this merge, the time work done, now you have to calculate. So at first we are having n elements at first. So when you merge those n elements, right, we have divided this into half. So we traverse first list, second list almost till the end for merging, right? So it's n. The work done is n. We are traversing because complete two lists, right? So it's n. Now in next level, n by 2, n by 2. Now we have this list, n by 2, n by 2. So when again we call merge on this, because actually the work done is in when we call merge method. So when we call again merge for this, what that merge will do? Here you have n by 2 element. So basically what this merge will do, all the elements, this is one list, this is one list. So we traverse, obviously we have to traverse all the elements. We have to copy all the elements, sorted list into this, and then again copy this. So ultimately we are traversing all the elements, n by 2 elements. So time taken or the work done is n by 2 for this, and same n by 2 for this. So if we compare at this level, if we add at this level also, it's n. Total is n. Like this, and next level also total work done is n. Like this. At every level n. So if you find out the total work done, then we just add n like this. How many times you will add this n? Whatever the height of this tree. What is the height? Number of recursive calls. We know it's a every time we are dividing by 2 by 2 by 2 till 1, so it's log n. It's complete binary tree, and height of a complete or full binary tree is log n. We know that thing we have already seen. So log n time we add. So it's like n into log n. The work done is n into log n. So the time complexity is order of n into log n. In all the cases, best, average, and worst, in every case, it's n log n. Okay. I hope you got the why time complexity is this. Height, I haven't explained why log n, because we have already seen the height of a tree is always log n. Right? Because ultimately, see, at this we have n, then n by 2, then n by 4, then till 1. So at height 0, it's n. So can I write n 2 raised to power 0? At height 1, because this is height 0, this is at height 1. All the nodes are at height 1. So number of nodes are 2 raised to power 1. At height 2, n by 2 raised to power 2. Till suppose I have here, suppose after k, height is k. So one here we have n divided by 2 raised to power k. Okay. And ultimately when we reach 1, so I can easily write 1 is equal to n divided by 2 raised to power k. Suppose after k steps or k height I've reached to 1. So I can write here n divided by 2 raised to power k, because in this form I'm keep writing. I'll keep writing. At height 0, it's n by 2 raised to power 0. At height 1, n divided by 2 raised to power 1. Something like this. So from this equation, 1 is equal to this. Can I find out what is k? Yes. Because I can write here 2 raised to power k is equal to n. Take log on both sides. So after taking log on both sides, k is equal to log n. And base is 2. So height is log n base 2. And at every height, at every level, the task or the work done is n. Almost n. In merge method. Right? So it's n log n. Time complexity. Space complexity is what? One is we are following recursive method. So definitely there would be recursive stack. The size of the stack would be, obviously we are going from here to here. This, then this, then this, then this. Then we go back, then we push this. Then we go back, do this. So when we go back, means backtracking means these frames would be out. Then we push this frame. Right? Then we do this. Then this frame is out. Then we push for this frame, and like this. So at a time, it's not that all the frame we push. No. This, then this, then this, then this. Like one is this, 2, 3, 4, 5. Then once we go back, this would be out, and then this means 5. So it's like almost according to the height of the tree, because height of this is almost, it's like we have 1, 2, 3, and 4. So log n. So that for recursive stacks, it's log n. But don't think that, okay, it's log n. Extra space also we are taking. What extra space? Temp, that temp array equal to that arrays, whatever array we have, that temp we need in merging sorted list. So the size of that temp is n plus n. So more dominating term is n. So we can ignore this. So space complexity is order of n. Space complexity is order of n. Time complexity is order of n log n in all the cases. Okay. Maybe you follow iterative approach. In that case, you don't need this log n, because that is in recursion only. We need call stack. There we need extra space n. Okay. I hope you got the working of merge, sort. Now you do one thing. Maybe you can try run this yourself first, or pause the video right now. If you get it, then code this out yourself. Size of this temp array would be whatever the size of this array. Now we have low would be 0 at first, we have high, or rather than taking this, you can simply call merge, sort, and there itself we pass array, and low rather than low it's pass 0, and high is what? Array dot length plus temp. Yeah, temp as well. We are passing temp as well, right? Here, let's define this. Make it static, void, merge, sort. So first we take an array, then we will have low, then we will have high, and one more array, temp. So for that also I'm having temp. Next, so we keep dividing first, but when low is less than high, till then we keep dividing. So when low is less than high, we calculate mid. Mid would be low plus high minus low divided by 2. And we call again merge sort. We keep dividing the array. Now the array is from low till mid. First half is this. Second half is merge sort array and start from mid plus 1 till high. Yeah, we need to pass temp also. We need to pass temp also. After keep dividing, now we merge. So we simply define a method merge. There we need to pass whatever array plus low and mid and high and temp. These three things. Yes. Now only one you need to define this method merge. So make it static, void, merge. First thing, we have an array, we have a variable low, we have a variable mid, then we have high, and one more array temp. Okay, let's define merge. So we have a variable int I is equal to at first low. Then we take j, I'll initialize this with mid plus 1. Mid plus 1. Because still low to that mid we have in the left array. From mid plus 1, second array start, second half start. Mid plus 1. Then we have one more k. K is equal to whatever the low is. Yes? Okay. Now we keep checking while my I is less than equal to low and my j is less than equal to high. Till then we keep checking. If my element which is at ith index is less than equal to the element which is at jth index. If it's less or equal, then in temp of k, I will assign array of I. Then I'll do I plus plus k plus plus. Or rather than writing in a separate step, I'll just write here k plus plus and I plus plus. It's post increment. So first whatever k value would be used, then it would be plus plus. So first k is 0. So at 0 we first put whatever the value at ith index. I is also 0 at first. Then we do both plus plus a plus k plus plus I. This is post increment. Else it's okay. In temp of k plus plus, I'll just store whatever at jth index. Then do plus plus. Simple. After this while loop. Now maybe any one of this half is exhausted, but we are still remaining element in any one half, whether in the left half or right half. So you need to check while for the both the half, while I is less than equal to mid, or it's less than equal to mid. Till then, whatever element in the I, same, we write k plus plus. We just going to keep copy paste all the elements here. Otherwise, maybe in j we have in second, we have remaining element. So j less than equal to high. Till then we do temp of k plus plus is equal to array of j plus plus. Yes, we are done. After this, now you have to copy the element from temp back to array, from temporary array to back to array. So for, I'll just assign I is equal to low and I is less than k and I plus plus. Till then, array of I is equal to whatever temp of I. Okay, here I is already defined in this scope because we have already I here, I is equal to low. So simply we just, rather than taking int, defining this, I is equal to low. Yes, we keep doing this. We keep pasting from temp array to array back till k only, till k, not temp length, till temp dot length, because temp length is 10. So for that it will give you 0, 0, 0. So yeah, we are done. Merging is done. Yes. So this is how we write merge sort. I hope it works. After this, if you want to print the array, so I'll simply print here arrays dot to string, whatever array I'll just pass. You have to include this also, java.util.arrays class from java.util package to use this inbuilt method to string from arrays. Let's try to run this and see it's working or not. Index out of bound. Okay. We can't pass array dot length because array dot length is 10. Yes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But high is 9. From 0 we start index, 0 to high. So it's array length minus 1. Yes. Now I run this. First half is sorted and second half is sorted, but not final array is sorted. Right? Okay, we have done something wrong here. Let's check our merge sort low less than high. Then we are just calculating mid and we are again calling this. That's right. We're calling merge also. In merge, what we have? I, j and k. Okay, sorry. While I is less than equal to mid, na, it's not low because I is already low and equal to low. While I is less than equal to mid and j less than equal to high, till then we keep moving. Alright, I got it. Now let's run this and see. So yeah, it's working now. 1, 3, 4, 10, 11, 15, 15, 18, 21 and 25. And it's stable. It maintains the relative ordering of the same elements. I hope you got it. It's not that much tough. You can easily code it. The only thing is this merge method. This is important to understand how to merge two sorted half of an array or two sorted list. That's it. If you know this thing, you just keep dividing whatever array is given to you till every sublist, every subarray is having only one element, and then we keep merging using this method. Now see, I have just taken this temp array here. If you take this temp array in merge, if you define here temp, suppose I here, rather than I'm passing here, I'm just defining temp. So what happens is every time when this merge will be called, a separate temp array would be created. So this will be extra space. Log n time this temp array would be created according to the height. So this time space complexity would be n log n. But it's not a good practice. You just pass at one time temp here. In main only create and pass the same temp, same temporary array. So at this point of time, it's n, order of n. And if you want to arrange this in descending order, it's okay. What do you need to change? Think about this. Pause the video and think about this. I hope you get it. Here you need to change a little bit. If this array of I is greater than array of j, then we put that in temp. So at first, whatever greater element that I'll put first, 25, 21 and like this. So this is in descending order. So yeah, that's it. This is how we do. Now one point is it in place? In place means within the same array, we just sort the array. No, but here we are taking a temporary array. So it's not in place. It's not in place. Merge sort, default version of merge sort, yeah. In place also we can do, but that is very complex, those variants of merge sort, so that are rarely used. This is used, this variant, this merge sort only. Is it adaptive? No, it's not adaptive. Adaptive because whether the array is sorted or not, it will not take advantage of that sorted array. The time complexity would be n log n. Every case, whether array is sorted given or unsorted or almost sorted or any array is given. So it's not adaptive. Yes. Always the time complexity is guaranteed. But this is the thing that it is guaranteed that when you apply merge sort, the time complexity would be n log n. That's good rather than n square. And it's stable also. But yeah, one drawback is extra space here we are taking. So there are millions of records, extra temporary array you need to take same size. So if you have memory constraint, we can't use this. You can go for quicksort. Quicksort also uh, go for this n log n. But quicksort doesn't guarantee that you have n log n time. I have discussed in worst case, quicksort can give you n square time complexity also. Right? But that's why merge sort is the optimal one because it guarantees that in every case you will get n log n, not n or n square. In worst, average, or best case. Right. So this is merge sort. Now we are done with quick sort as well. Now in the next lecture we will see these all are comparison based sorting. We were comparing the elements, right? Which one is smaller, which one is greater. According to that we uh, place the elements. So bubble, insertion, selection, merge, quick. These are comparison based sorting. Now we'll discuss non-comparison based sorting. Count, predicts, bucket. Right? So that thing we'll see in the next lecture. Bye bye. Take care.